So good day to all. Today we can discuss about the facets of data in the subject foundations of data science. So what is the meaning of these facets of data? So when we go for data science, data exists in many forms and understanding these forms is the first step in data science. The term facets of data refers to the distinct categories or types of data that a data scientist encounters in real world scenarios. So each facet has its own characteristic, storage requirements, processing techniques, and challenges. So there are several categories. We are just going to discuss about the seven main categories of data. So structured data, unstructured data, natural language data, then machine generated data, graph based or network data, then audio or video, images data, and streaming data. So these categories are not mutually exclusive. Real world data often blends multiple types. So first we can discuss about the structured data. So the structured data, this data is depends on a predefined data model and resides in a fixed field within a record or file. So every field has a clearly defined meaning, a specific data type, and a set position. So mainly easy to store structured data in table forms within databases or Excel files or structured query language will be coming under structured data. So what are the main categories we can see are it should be organized into rows and columns, that is tabular format, and each column has a name, data type, and a constraint. Example, integer, string, date, like that. So languages like SQL and relational databases, spreadsheets, CSV files are to be supported. Next is unstructured data. So this unstructured data is data that does not conform to a predefined data model or schema. It doesn't have any predefined structure like structured data spread as rows and columns. So the content is context specific. From it will be varying in length, and a major example we can quote for this is having a email. So why we are calling it should be a unstructured data? You consider an email, while it has some structural metadata, sender, recipient, timestamp, everything. The body of the email is free from text. Two emails about the same topic may use completely different words, sentence lengths, languages, and writing styles. So the email example uh, is mainly because people preferring to the employee by first name, last name, nickname, or job title. So whatever maybe it will be having a not in a structured format. It should be having like some different structured, and some emails will be having some attachments like images. Some will be having like a PDF reports. Some will be having handwritten like, so it is not having, this is the predefined like that. So it is a challenge to find the number of people who have written an email complaint about a specific employee, because so many ways exist to refer to a person. So this is about this unstructured data. Next is natural language. So natural language refers to any language that is developed naturally in humans. So English, Tamil, Hindi, French, etc. Are based on your preferred language. So natural language is a special type of unstructured data because it encodes meaning, emotion, culture, and context in ways that are extremely difficult for computers to interpret. So it will be a challenging one. So topics and mainly in natural languages, entity recognition, topic recognition, summarization, test completion, and sentiment analysis. So because each person will be composing using his own grammar, vocabulary, idioms, and rhythmical style like that. So it will be different. So no two emails are identical. We can say again. So, and even two emails with the same intent may be worded completely differently. So, it is actually natural language will be also coming under a unstructured data. Why is it? Because we are telling it's a very challenging issue because this, for example, some wordings will be stressed. Some wordings will be not stressed. So, it will be depending on our own way of communication. So example, we can say chatbots, then virtual assistants like Sri, Alexa. These are some examples we can say for natural language. Then with the major example, Google Translate. Okay, so next is machine generated data. So machine generated data is information that is automatically created by a computer, process, application, sensors, or other machine, extremely without human intervention. A human does not write this data. Instead, machines log, record, and transmit it continuously as part of their operation. So, why is it a major resource we are telling it is? Because nowadays the world is connected with many devices, machine generated devices, smartphones, IoT sensors, industrial machinery, work servers, network routers, satellites. So these have many machine generated data, the largest and fastest growing category of data in existence. So for a data science, this data is a very gold. We can have the examples of machine data as web server logs, call detail records, network event logs, telemetry systems. So many examples are there. So my modern example, smartwatch health data, heart rate, steps, it is calculated, right? GPS tracking in delivery vehicles. Many things are available as examples for machine generated data. So next is graph based or network data. So what is a graph in data science and mathematics? A graph does not mean a bar chart or pie chart. It refers to a formal structure from graph theory, a branch of mathematics used to model relationship between some objects. So a graph consists of some nodes. So the nodes means the objects or entities in the graph. For example, people in a social network, cities in a map, or web pages on the internet. Then second thing, edges. What is the meaning of edges? So the connections or relationship between these objects. For example, friendship between two people, a road between two cities. Like that, it will be interconnected. Then it will be having some properties. What are the properties? Some of the attributes attached to nodes or edges. For example, a person's name and age is a node property, or the distance between cities. That is a for edge property. So there will be a calculation of many shortest path. These are the capabilities of graph data, shortest path calculation, then influence analysis, community detection, recommendation, or that is giving some suggestion based on the way it is represented. So examples we can quote LinkedIn, Twitter, movie interest on Netflix. Many will be having some it will be connected from one to other by giving some likes. Some will be giving unlike. So based on that recommendation, we can go for from the graph-based data, we can go for some examples. So mainly the typical examples are so road navigation, Google Map, shortest route we are going right day by day. And then fraud detection, unusual transaction patterns, everything will be coming under graph-based or network data. The last one is the audio, image, and video data. So audio, image, and video data represent some of the richest and most computationally challenging data. So it will be forms, so there are several forms. So unlike text, which encodes information in discrete symbolic tokens, and it will be transferring the data. So high-speed cameras at stadiums capture ball and athlete movements to create calculate in real time. So many things available. DeepMind succeeded at creating an algorithm capable of learning how to play video games. Then audio recordings like stored data or exams. So mainly sport analytics, DeepMind and video game learning. Google's AI development plans are examples for audio, image, and video. So it depends on our requirement, what are the ways we need. So mainly medical imaging, X-rays, MRI scans, then facial recognition, autonomous vehicle, AMRs, satellite image analysis for agriculture and disaster management. All those comes under this audio, image, and video data. The list is streaming data. The streaming data refers to data that is generated continuously and flows into a system in real time, event by event, rather than being collected in bulk and loaded all at once. It is now a live streaming of cricket example, we can say. So it will be having few fundamentals. As a batch, we can have the data or versus streaming. So batch processing means at the end of the day, the bank will be collecting all the data and it is going to process. Stream processing means data is processed at the instant it arrives. So credit card transaction, at a time it will be detecting and giving a message that your credit card is in use, like that. So what's trend? Examples we can say what's trending on Twitter, the live sporting events, then calculating the people's live music events, stock market prediction, all will be coming under the streaming data. So there will be many tools available for getting the streaming data. So that will be coming under a separate category. So this is about the facets of data. So we have discussed the 7 facets of data. One is structured, this unstructured, natural language, machine generated, graph-based audio, video, and images streaming. So hopefully you have understand everything. All these data are now interconnected to our day-to-day life, in which the huge data is collected for some of processing techniques. Thank you.